Hello everyone and welcome back. My name is Mr. Cobalt, and in this video we're going to find out how to figure out what the molar mass of an unknown metal is by the reactions it undergoes. So let's get into this. So in this problem we're given 1.00 grams sample of a metal X, and they tell us that it's known to make 2 plus ions, so an X2 plus ions. Um, and this was added to 0.100 liters of 0.500 molar H2SO4 or sulfuric acid. After all the metal had reacted, the remaining acid required a 0.0334 liters of 0.500 molar NaOH solution for neutralization. Calculate the molar mass of the metal. So right away, when they're asking you to find the molar mass of the metal, you got to go back to what does molar mass mean? What is the definition of molar mass? And so if we remember molar mass, and I'll just say MM for molar mass. So molar mass is equal to the number of moles of the, I'm thinking molarity, not molar mass. So it's equal to the grams, the mass in grams per mole of the substance. So we're looking for grams per mole. Okay, so if we could find grams and then we could find moles of the substance of the metal, then you could just divide those two and we get our molar mass, and then we can identify what the metal is, right? So it happens that they gave us 1.00 gram sample of metal X. Well, there's our grams. So all we need to do is find out how many moles that is, and then we divide the two and we get our molar mass. So how do we find the moles of the metal that we start with? Well, that's where the reactions come in. So we know that the metal reacts with H2SO4. We know that it forms X2 plus ions. So that helps us write a balanced equation. So I'm going to take my metal X. It's going to react with H2SO4. Now, the thing about your metal is that when it reacts here, it's going to kick off the hydrogen. So this is a single replacement reaction. So the metal is going to kick off the hydrogen and form a ionic compound with the sulfate. So then that's going to form sulfate ion is a 2 minus charge. We're told that the X, our metal, forms 2 plus ions. So that's going to be a 1-to-1 ratio in our formula. So this is going to be XSO4. And then we have our hydrogen. So we're going to have hydrogen gas left over. So this is our formula for the metal sulfate, our metal and our sulfuric acid. So all we need to do is make sure the equation is balanced. We got X, 1X, 1X. We have two hydrogens. We have SO4 and SO4. So this is balanced. So we got one balanced equation that's going to help us. Now, one of the things it tells us is that the metal sample that we have does not react completely with the amount of sulfuric acid we're given. So after the metal reacts completely, we have some leftover sulfuric acid. And they tell us that it takes 0.0334 liters of 0.500 molar NaOH solution to react completely with that. So that's going to be important. So let's go ahead and write that reaction down. So we have H2SO4 reacts with NaOH to form water, because the hydrogen, the hydroxide are going to come together to form water. And then we have our sodium is going to come together with our sulfate. Our sulfate again has a -2. Our sodium has a +1, so we need 2 sodiums to balance the charge of our sulfate. So that's going to be Na2SO4. Let's make sure we balance the equation. So we have 1 sodium, we have 2 sodium, so we should have a 2 here. We have 2 hydroxides, we have 2 hydrogens. That's going to come together to form 2 waters. So we're going to need a 2 there. And then we have 1 sulfate, 1 sulfate. So here's our balanced equation. So now that we have the 2 balanced equations, we can go ahead and start figuring out the number of moles. And we're going to use stoichiometry. So we're told that it takes 0.0334 liters of 0.500 molar NaOH solution to react with the leftover acid. So we could use that to find out, well, how much leftover acid was there? Because then we could use that to figure out, well, whatever didn't react can be subtracted from what did react. So let's first figure out, well, what was the total number of moles of H2SO4 that we had to begin with? So to find that, we're going to take the liters of our H2SO4. So we got 0.100 liters of H2SO4. And we want to know what the total number of moles of the acid we had to start with. So this is where your molarity is going to be important, because you can use molarity as a conversion factor. So again, let's look at molarity, this time capital M, 1 capital M. Molarity is equal to moles over liters. So your moles of the solute, which is what's being dissolved, that would be your H2SO4, and liters of the solution, that would be the solution that the H2SO4 is dissolved in with water. So we can use this to convert between liters and moles of the solute. So they told us it's 0.500 liters, right, or molarity, right? So that means that it's 0.500 moles of the H2SO4 per liter of the solution. So here we're going to put 1 liter of the H2SO4 solution, and then on top we have 0.500 moles of H2SO4. Liters are going to cancel out. So if we multiply 0.100 times 0.500, we get 0.0500 moles of H2SO4. So that's the total amount of H2SO4 in our original solution. So now we can figure out how much was left over. So we're told that 0.0334 liters of our NaOH solution was used to react and neutralize whatever the acid was left over. We can use that, and we can use stoichiometry to convert from the liters of the NaOH that was used to neutralize the leftover to find out, well, how many moles of the leftover acid was there that got neutralized. So we're going to start with 0.0334 liters of the NaOH solution. Okay. And then we're going to use the molarity again of our NaOH solution to convert from liters to moles. So again, we have 0.500 molar. So again, that's going to be 1 liter of the NaOH on the bottom, and that's going to be 0.500 liters, oops, not liters, moles of the NaOH in the solution. So now the liters cancel out. I have 0.500 moles of NaOH. So now I can convert moles of NaOH to moles of H2SO4 using the mole ratio in my equation. I know that for every 1 mole of H2SO4 I have, it requires 2 moles of NaOH to neutralize it. So it's a 1-to-2 ratio. So I'm going to use that to convert to moles of NaOH. So on the bottom, moles of H2SO4. So on the bottom, I'm going to put the 2 moles of NaOH. So 2 moles NaOH. And I'm going to put on top 1 mole of the H2SO4. And that's what I want. So I'm going to cancel out moles of NaOH. So now I can calculate the number of moles of H2SO4 that was left over. And when I calculate that, I get 0.00835. So it's going to be 0.00835 moles of the H2SO4 that was left over. So this was H2SO4 unreacted. So now that we have the number of moles of the H2SO4 that was unreacted, this is the number of moles that was left over, right? Because this is what got neutralized by the 0.334 liters of NaOH. So if this is left over, and this is the total amount that we started with, if I subtract this from this, we'll get the number of moles of the H2SO4 that was reacted with the original metal X. So let's go ahead and do that. So we have 0.0500 moles of the total H2SO4. We subtract out the leftover, the unreacted amount. So subtract 0.00835 moles of the H2SO4 that was unreacted. And then when we subtract those two, we get, what do we get? 0.04165. So 0.04165 moles of H2SO4 reacted. So this, ladies and gentlemen, is the number of moles that reacted with the amount of metal X that we were given to begin with. Okay, so now that we have the amount of acid that actually reacted with the metal, we can now use stoichiometry to work backwards from the reacted H2SO4 to the moles of metal that we started with. So let's go ahead and do that. I'm going to erase this now since we don't need this. Okay, so here we're going to start with a 0.04165 moles of H2SO4 that reacted with our metal X. So now I can use this equation to do stoichiometry. So this is the H2SO4. So here's a 1-to-1 ratio. So 1 mole of X is going to react with 1 mole of H2SO4, so I can do my mole ratio. So on the bottom, I'm going to have 1 mole of the H2SO4, and then on top, I'm going to have 1 mole of our metal X. So moles cancel out, and of course, it becomes 0.04165 moles of X. So now we have moles of X. Let me just double check to make sure. Yep. So now that we have moles of X, we have the grams of X that we started with, 1.00 grams. So now all we need to do to find the molar mass is divide the grams by the moles. So I'm going to take 1.00 grams of X, divide that by 0.04165 moles of X. And when I divide that, I get 24.0 grams. So 24.0 grams. And then that is, grams per mole, I should say. And that's the molar mass of our metal. And when we look up on the periodic table, you can identify that as magnesium. And it makes sense because magnesium does indeed form 2+ ions. So that's it for this video. I hope you enjoyed the video. I hope this video helped you a lot in how to solve these type of problems. If it did, then please, by all means, help me out. Like the video, share the video, subscribe to my channel, hit that notification bell when you do. Make sure that you click all so you'll be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a problem or a question you need help with, or if you have a topic you would like me to cover, put that down below. I would love to do that for you. Thanks for joining me, and have a great day.